Up until this point, we've only considered travelling north to south or east to west along the surface of the Earth. So in this video, we're going to learn about calculating distances between points when we travel diagonally across the Earth's surface. So southeast or northwest, but not exactly necessarily in those directions, but just not directly north, south or east, west. Now when we do that, we're actually travelling on what we call a great circle. So you can see between points P and Q here that that's a part of a great circle. Okay, so this great circle is the largest circle you could produce on the surface of the Earth, the largest possible circle. And it just happens to be exactly the same as all the lines of longitude, so those lines that travel through the North and South Pole. When we're travelling north or south, we're on a great circle. The equator is a great circle. So really the only time we're not travelling on a great circle is when we're going east to west, not on the equator. Then we're on those smaller circles. So we've got to use a different formula here to begin with. Let's have a look at that. So this formula looks big, this one here, and it is big, but it's not that hard to use once you get the hang of it. It involves the latitudes of the positions and the angular separation, or the difference in longitude. So probably the best way is for me to get straight into an example with you. So let's have a look at this one. We're going from Rome to Melbourne. We want to find the distance in kilometres. So we're going to use the latitudes, and I'll colour code this to hopefully make it a bit easier to see. And we've got a longitude as well for each place, which we're going to use to find theta, our longitudinal difference. So let's do that first. Both places are east, so just like in previous examples, we work it out the same way. They're both east, so we'll subtract those two to get our longitudinal difference. So the longitudinal difference is 137 degrees. Alright, I'll keep that for later when we put it into the formula. So we're going to use that big looking formula where we have cosine of theta equals, okay, we've got the sine of the latitude of the first place. Doesn't really matter what order you do it in, but I'll put Rome first. So sine 43 times sine, and then we put Melbourne's latitude. So that's where, like, Rome would be like point P and Melbourne would be like point Q in this formula back here. Okay, so Melbourne's latitude is 38 degrees south. Now this is the only time we need to consider this, because it's a southerly latitude that goes in negative. It's the only time you need to worry about north-south, positive, negative. So a bit like on the way that the Google Earth worked with its latitude, longitude positions. North was positive, south was negative. Okay, then we repeat those, but we have cosine, so cosine, and we'll put Rome's latitude, cosine with Melbourne's latitude, negative of course, and then we put the cosine of the longitudinal difference, the 137, goes right there. So we write this out like this, and we have the sine of the first latitude times sine of the second latitude, then cos of those, and then that longitudinal difference there. It's a big formula, but with practice it is quite logical. It's not too hard to use. Putting it into the calculator is a different matter though. Now what you need to type into the calculator is this. We want to rearrange this and get theta on its own. So we have theta equals inverse cosine of all this stuff here. See, the cosine comes over just like regularly. Of course, we're not going to type theta equals. I'll just write down what I want you to type into the calculator. This is what you want to type into the calculator. Now this can be a challenging thing to do. You're just going to have to practice and try and get the same answer as what I get here. Oops. Okay, so you're going to type all this stuff. So starting with inverse cosine and then sine 43 times sine negative 38, so forth. Close that bracket at the end. Now what you should get is 147.285 degrees. Okay, so then we just revert to our previous formula for longitudinal difference. D equals 2 pi by the radius of the Earth by, now this number, 147.285, that's like our theta value. That goes over 360, just like we did before. So we're still just using this formula from earlier, but we've got this step at the beginning with this cosine of theta to get the angle between them. Okay, so we put that into the calculator. We should get this distance here. That many kilometers. Okay, so similar to before, but we've got this bit at the beginning to think about up here. So practice getting this into the calculator and getting that number. Make sure you can do that, and then it's just a matter of putting it into the formula that we already knew. Okay, so go ahead and try those.